What's up, everyone? Today we're going to go over Leetcode 257. Now the input is going to be a binary tree and the output is going to be a list of strings. And what we need to return is all the root to leaf paths. For example, 1, 2, and 5 is one of the strings and 1 and 3 is the other string. So let's say, for example, we have binary trees, right? Because they're asking the direct path from the root to leaf, we know we can take a DFS approach. If they were asking us something to do row by row or layer by layer, that would be a BFS approach. Now we are going to choose this one because the question is directly asking us to return the paths. So let's look at how we can calculate this. Okay, now I've drawn two binary trees, and I'd like to point out a subtlety, even though this problem is tagged as a Leetcode easy. Now, let's say we were trying to do an in-order traversal of this tree. What might that look like? So that's pretty straightforward. And how can we generate this? Well, all we do is just take a list of integers and we pass it in our recursive tree. So we pass that, and each one of these nodes is going to append itself when it gets a chance. So 2, 5, 1, and 3. So what you have to note here is that each node is sharing the same object. So every time a node gets control of the recursive stack, it's going to append itself to the list, but they're all sharing the same list. In the problem that we're solving right now, this is not the case. We're not going to be passing an object like a list of strings or a set of integers or anything like that, but we're going to be passing a string. So that's just an empty string. Think of it like a empty array list, but this is what we're going to pass to 1. And then 1 is going to append itself to the empty string. Now what 1 is going to do is it's going to give each of its children a separate copy. And each child is going to append itself to their own copy. Similarly, 2 is going to give its copy, like a brand new copy, to 5, and 5 is going to append itself to that. Now you can clearly see the string that each node is generating when we're doing our recursive calls. Since the question asks that we collect all the strings that traverse down the root to leaf paths, all we have to do is collect the 3 and the 5. Now I'm going to show you an algorithm visualization so you can understand it a bit better. Cool. Now that you've seen the visualization, let's briefly go over the code. The code is pretty short and concise since it's recursive, but let's just walk through it. Now we have a list of strings, which is the result, and this is our recursive DFS call, and we're trying to return what we're populating. So if the root is null, we simply return, and every time a node gets control of the recursive stack, it's going to append its value to the path. So in the beginning it was empty, and then when 1 gets control of it, it's going to be 1. That's the value of the path. And then it's going to recursively give a copy to its left and right children, while appending the arrow, because that's what the question wants, to the path. And if a node's left and right child are null, meaning it's a leaf node, then it's going to add its own path that it's received to the result. So the time complexity is going to be O of n, where n is the number of nodes, just because we're going to have to visit every single node since we're recursively checking left and right child. And the spaced complexity, I'm going to just say it's the output size because we're not really using, extra spaces. The question is asking for a list of string, and we need to visit nodes. So depending how you define the space complexity, like if you're visiting the node or the recursive stack, I'm just going to say it's the output size. So that's how you solve Leetcode 257. If you liked the video, please let me know, and thanks for watching.